Hey, Dr. Ray here, founder of the Learning Liaisons, and welcome. Welcome to our Wednesday evening math sessions featuring our math specialist and your math specialist, Amy Sink. In the next hour, Amy has put together a sample set of approximately 10 practice questions that run the gamut from kindergarten levels all the way through 12th grade high school math. Now, I know you are attending here, watching this, and you're like, well, I'm doing elementary in Texas, or I'm doing elementary in Praxis, or I'm doing high school math in Florida, or middle school math in Texas. And what's going on here, right? So we're doing these sessions to help you guys out and provide you with different ways to look at problems and to build that confidence. Because here at the Learning Liaisons, one of our major objectives is to clear up the testing confusion, give you the support you deserve in order to nail your exam and be done with it. So our focus is on math. Now, are we going to be just focusing on high school math the whole hour or elementary? No, we've got a mixture here. Now, Amy's going to go through a bunch of problems. You're going to have the opportunity to download those as a PDF. So when Amy starts, just pay attention to the screen. We're going to have a message there for you so you can download the PDF in case we don't get to all the problems or want to practice on your own. She's going to do her best to go across all different grade levels. If you have a question, you feel free to ask Amy your question as well. We're teachers here too, so we can multitask. Our job is to make sure that we give you what you need to be successful. But if you're like, dang it, I didn't have any questions this week, don't worry. We'll be here next Wednesday night as well. So bring those questions with you if you want, and you can ask Amy away. Because here at the Learning Liaisons, we pride ourselves in providing you guys the support you need to pass your exam. So whether you're our Florida teachers here with our FTCE exams, our national exam, Praxis peeps, big shout out to you guys out there too. And especially our newcomers to the Learning Liaisons brand, TExES Prep. So whether you're elementary, middle school, and high school, we've got your back. So sit back, relax, grab your popcorn, get ready to learn some math, and stay tuned for the end because I'm going to jump back on to close this out. And I got a special surprise for you guys who really want to get the real deal prep and get everything you need to be successful and practice, clear up that confusion, and pass your certification exam on the next attempt. So, welcome to the Learning Liaisons community. Always remember, it's when you pass, not if you pass. So without further ado, let's turn it over to the reason why you're here, Amy. You with us, Amy? Let's get going.
Hey everybody, welcome to Wednesday night math night. I feel like the camera's like weird. Welcome to Wednesday night math night. I am so excited to be here with you guys. As always, I so look forward to these Wednesday night math sessions where we can just do math together. It's a little casual today. I've got my glasses, my headband. So we are casual today as we do Wednesday night math night. But I truly love being here because it allows us to serve you and help you with what you are struggling with. So, like Dr. A said, I am Amy Sink, and I am one of the math specialists here at the Learning Liaisons. Hi, Susanna. It's so good to see you. And I am certified in K-12 mathematics in the state of Florida, as well as educational leadership. And these tests are not easy. Let's just start with that. They're not easy. And they try to trick us. And so we're just here to gain a little bit more confidence in math. So before we get started, I always like to do a little get to know you. So in the comment box, let me know where you're from, what test are you prepping for, and what is a hobby that you have? What is a hobby that you have? I absolutely love to choreograph productions. And so a hobby that I have that I do outside of my normal job is choreograph for theater productions in the area. I grew up as a dancer. I grew up in competitive dance. And so I love to use that skill set to choreograph for theater productions. Hence the shirt, one last time from the top, 5, 6, 7, 8. So it is a side of me that not my school people don't get to see, but my theater people do. And so that's a passion of mine. Hey, Susanna, it's good to see you. Hey, Lena, EC6, awesome. You like to work out. You like to dance. You fit right in with me. North Carolina, that Praxis 7813. No hobbies. That, you know what? It took me a long time to find my hobby. Hi, Maria from South Texas. You just passed your EC 391. Awesome. And you would like to be certified for math 4 through 8. You can do it. If you can do it. The math does get a little harder, but you can absolutely make it happen. Hi, Lydia. Texas, the EC6. We got quite a few people with the EC6 and 7813. And you like to play video games. I wish I could get into video games. I get lost and dizzy in like video game world. So I have to play a very like 2-dimensional game where like it's not 3-dimensional. You're not going around. Otherwise I get lost. So I like Mario Kart is about as 3D as it gets for me. Hi, Shayla. Houston, you're taking the writing test. Now, Shayla, I am so happy to meet you. I can write, but I am not here to help you with writing tonight. We are doing math only. So if you want to hang out with me today, I'm happy to have you. But I am not going to be helping with anything writing today. Now, word problems, maybe. Absolutely, we'll be doing that. But we're not doing writing prep today. In fact, no Wednesday do we ever do writing prep. We only do math prep on Wednesdays. So I guess that's it. If you have any questions, you can always let me know in the comment box, and I like to add them to my next week section. Next week. So if you have any questions at all, just let me know, and I'll add them to my next week section, because these sessions are for you. They're not for me. They're for you. I love doing them, but I want to make sure that I'm addressing concepts that you need help with. So whatever you need help with, you let me know, and I'll add them to the next week's session. We are going to finish a couple of minutes early today. My son has, he's graduating from swim lessons this week. And so we have to be at swim lessons earlier than usual for whatever, reason, for part of the little graduation or whatever. So we will be finishing up just a couple of minutes early. So we may not get through 10 problems or 8 problems like we normally do. It may be only like 6 or 7. All righty, let's go ahead and get started with problem number 1. If the pattern continues, how many blocks will there be on the bottom row of the 8th figure? If the pattern continues, how many blocks will there be on the bottom row of the 8th figure? All right, this is an interesting problem. So many times when I see people ask for help for problems like these, I see people say, use an arithmetic sequence or use a geometric sequence. And you really can't use an arithmetic or a geometric sequence unless the pattern is adding or subtracting by the same amount every time, or if the problem is multiplying or dividing by the same amount every time. And that gets really tricky because people think that if I'm adding 2 and then adding 3 and then adding 4 and then adding 5, that would be an arithmetic sequence because there's a pattern, but it's not an arithmetic sequence because I'm not adding 2 every time or adding 4 every time or adding 6 every time. I'm adding in a pattern, but I'm not adding the same amount every time. So I can't use my arithmetic or geometric sequence formulas to solve that problem. Now, what is an arithmetic or a geometric sequence? Well, that's just kind of like a rabbit trail. But an arithmetic sequence is a sub n equals a sub 1 plus n minus 1 times d, where a sub 1 is the first term in the sequence. D is the common difference. So what are you adding? What are you subtracting? And n is the number term that you want. This I do not like memorizing formulas. I just don't. So with that said, I don't keep the arithmetic and geometric sequence formula in my brain. Beth, I'll answer your question in 1 minute. I don't like to hold those in my brain. So that said, because of that, I usually will do arithmetic and geometric sequences in my calculator. This comes in handy when you're like, when it says like find the 432nd term of the sequence, right? Because you don't want to sit here and go plus 2, plus 2, plus 2, 432 times. So that's really where the formula comes in handy. But I've got a secret for you. My secret is when I took my tests, now again, you could have a very different test than mine. But when I took my certification tests, I never used the arithmetic or geometric sequence formula. They were always just far enough or close enough that I was able to use the calculator. But back to this problem. Back to this problem right here. So I notice in figure 1 that we have 3 cubes. And I notice in figure 2 that we have 3, 4, 5, 6 cubes. And I notice in figure 3 that we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 cubes. How are they adding cubes in this problem? Well, if I start with my base shape, here's my base shape. They added 3 to the bottom. 3 plus 3 is 6. And then here is my base shape. What did they add? 4. So then they're going to add 5 and then 6 and then 7 all the way until they get to the 8th figure. But what did the question ask? The question asked, how many blocks will be on the bottom row? So I don't even need to do all of that. I only need to look at the bottom row. 2, 3, 4. So it's going to keep going up. 5, 6, 7, 8, 9. That's all it's going to do. So if figure 1 is 2 and figure 2 is 3 and figure 3 is 4, then figure 4, 5, 6, 7, 8. How many blocks are going to be in the bottom row of the 8th figure? 9 blocks. You do not need to know a formula to be able to do this. Let me go ahead and answer some questions. Lina, this problem was on your test. This is a very, very common type of problem. Now, exactly what the blocks look like, different every time. But how it's worded, absolutely. Patterning is often a problem that's on tests. You did not come in late. You just missed my introduction. So that's it. I have not reviewed the gallon solution problem, but it is on deck for tonight. We are going to go over gallon solution problems. And Lydia, you can't see what you are writing. Is anyone else having a problem seeing what I'm writing on the top? Because from my end, it looks good to go. But if anybody else is having a problem, let me know. Hi, Ernell. You're a grade 5 student doing prep. Prep for what? Are you taking a test soon? You're not having problems. Okay, Lydia, it might just be that you accidentally zoomed in or something like that. So, I don't know, try again. I don't know the solution to that, but everybody else seems to be able to see it. So, at least that's good. All righty. Problem number 2. A wrapping paper service, not surface, wrapped the exterior of a rectangular prism-shaped box that measured 9 inches by 10 inches by 12 inches. Using exactly 1 sheet of rectangular shaped paper that measured 3 feet by 4 feet. There were no gaps or overlapping paper. How many square inches of wrapping paper were left over? How many square inches of wrapping paper were left over? Beth, I also have that in for tonight. So this is an interesting problem. This is a geometry problem. And it's a problem that is really talking about surface area, but our brain wants to think that we're doing volume. It's a problem that thinks that we're doing surface area, or thinks that we're doing volume, but we're really doing surface area. Let's take a look at how to solve this problem. So I always like to draw my box, but I know that not everybody necessarily likes to do that. So I'm just going to draw my box like that. And we know that it's measuring 9 by 10 by 12. The order of those doesn't matter at all. It just doesn't. So because multiplication is commutative, and even if I'm not doing volume, but I'm doing surface area, multiplication and addition are commutative. So it really doesn't matter what order we do it in. All right. So when I'm doing surface area, if I were to I'm going to use my notebook as an example because it's the only thing I have around me that's kind of shaped like a rectangular prism. So with this notebook, I have my longer side, my shorter side, my top, and my bottom. How many sides do I have that are this size in this prism? 2. I have my top, that's that size, and I have my bottom, that's that same size. So I have 2 that are the same size. How many of these sides do I have that are the same size? 2. I have my front and I have my back. And then how many long sides do I have that are the same size? How many long sides do I have that are the same size? 2 as well. 1, 2. So when I'm looking at solving this problem, I have 2 of each type of rectangle. So I'm going to draw my top, my front, and my back, and my side. My top, my front, and my side. My top is going to be this right here. So we have 12 and 12, 10 and 10. So I have a 10 by 12. Then I also have a 9 by 10, which is right here. And then I also have a 9 by 12, and that is the hardest one to see. And that is technically right here, 9 by 12, because if this is 9, then this is 9 as well. And we already decided we have 2 of all of them. So in order to figure out how much wrapping paper I need to figure out the surface area of this shape. I'm not trying to figure out how much wrapping paper goes inside the box. I'm trying to figure out how much wrapping paper can fit on the outside of the box with no gaps or overlapping paper. Now, you and I both know that's not how you wrap like a box. I don't sit and cut out exact shapes and tape them together, but in this story, that's how it goes. So, with that said, I'm going to find the area of each of these smaller rectangles first. So 10 times 12, because to find the area of a rectangle, remember, you're going to do length times width. So I'm going to do 10 times 12. I'm going to do 9 times 10, and I'm going to do 9 times 12. 10 times 12 is 120. 9 times 10 is 90. And 9 times 12 is 108. Now, remember, we have 2 of each of those. So 120 times 2 is 240. 90 times 2 is 180. And 108 times 2 is 216. What am I going to do with that information now? What am I going to do with that information now? Now I'm going to add all of those up because that's going to tell me the surface area of my entire box. So 240 plus 180 plus 216, I'm going to use my calculator, is 636. What does that number represent? If you have ever been in a math class with me, you know that is the age-old question I'm always asking. What does 636 represent? What does 636 represent? It represents the surface area of the box. But that is not what they asked for. So that is not the correct answer. They asked for how many square inches of paper were left over. So now I need to figure out how much wrapping paper I have. Well, some of you are like, well, just do 3 times 4. You're absolutely right. Except 3 times 4 would give me how much wrapping paper I have in feet. I don't want feet because everything else I'm doing is in inches. I don't want feet because everything else I'm doing is in inches. So I need to go ahead and convert those feet into inches. So I'm looking at my iPad right now and I see that I have 3 feet by 4 feet equals 12 square feet. But I cannot take my 12 square feet and then multiply it times 12 to convert it into inches. If you have been a part of a couple of these math sessions, you know linear measurements and square measurements are not the same. So I can't take a square measurement and multiply it by a linear measurement and expect to get the right answer. I need to convert before I find my area. So I need to do 3 times 12 to figure out how much this length is in inches. I need to do 4 times 12 to figure out how much this width is in inches. And then I need to find the square inches by multiplying those numbers together. So 3 times 12 is 36. 4 times 12 is 48. And I do not have 36 times 48 memorized. 36 times 48. 1,728. Here's my age-old question. What does that number represent? That number represents the wrapping paper. So now all I need to do is 1,728 minus 636, which is going to give us 1,092. Questions? Questions. All right, let's move on to problem number 3. Here's the solution problem. Let's go ahead and read it. Which of the following equations can be used to find the number of gallons of a 50% alcohol solution, X, that should be mixed with 10 gallons of a 35% solution in order to get a 40% solution? This is such a interesting problem because it's not a common problem that we like necessarily see, right? It's not a common problem that we necessarily see every day. And so it gets a little like, it just kind of makes us all like, that's interesting. So let's go ahead and solve it. So which of the following equations can be used to find the number of gallons of a 50% alcohol solution that should be mixed with 10 gallons? Like so many numbers, right? So bye, Erno. Good to see you. Thanks for joining us. All right. So I like to look at my answer choices when it comes to this kind of stuff. I like to look at my answer choices. So I know that I'm going to have to take my 50% solution and multiply it by some gallons. I'm going to have to take my 35% solution and multiply it by some gallons. And it's going to equal a 40% solution multiplied by some gallons, right? Because if I'm combining my 50% gallons and my 35% gallons, it's going to equal a 40% gallon. Does that make sense? And sometimes we just have to take it and break it down to that level. So I need my 50% gallons plus my 35% gallons, and that's going to equal my 40% gallons. Now, unfortunately, nothing looks like that. That's okay, because we can at least take that frame of mind and use it to our advantage. So when I look at this problem, I see that we have 85% times something. Well, I cannot add my 50 and my 35% together because they're percentages of a solution. So I can't add those percentages together because it's not the same scientific solution, if you will. So it's not going to be A. And I know it's not going to be B because I have everything else in percentages and then a random 5 for 50%. That doesn't make sense. So it can't be B. You see how I'm looking for like things that are just a little out of whack, right? Then I have 50% times gallons plus 3.5. Well, 35% does not equal 3.5. However, what we do know is that 35% times X, how much of the 35% solution do we have? How much of the 35% solution do we have? 10 gallons. What is 10 times 35%? What is 10 times 35%? 3.5. So that does make sense. Let's come back to that. And then we have 0.5, 50% times some gallons, plus 35% times no gallons. That doesn't make sense. So we have 50% times some gallons, 35% times some gallons, because that is the solution to that, and 40% times some gallons. Without even understanding this problem, we can get to the right answer. Just by knowing that I need to have a similar format to this. 50% times some gallons plus 35% times some gallons equals 40% times some gallons. Now, where did they get the X plus 10 from? That's a great question. Where did they get this X plus 10 from? That X plus 10 came from the fact that we are mixing some gallons here with 10 gallons to get a solution. So if we are mixing gallons plus 10 more gallons and it's going to equal a larger solution, here's my gallons plus my 10 gallons that is going to equal that 40% solution. That's where they got the X plus 10 from. Does all of that make sense? These problems are so confusing and so hard. Let's go ahead and do another one that is very similar to this. Let's do another one that's very similar to this. And that way, now that this is fresh in your mind, maybe you can like start to solve it on your own. Coffee beans are sold at a local coffee shop for different amounts per pound. Coffee worth $1.20 per pound is mixed with coffee worth 95 cents per pound to obtain 35 pounds of a mixture worth $1 per pound. How many of each type are used? A, 28 pounds of $1.20 coffee and 7 pounds of 95-cent coffee. 7 pounds of $1.20 coffee and 28 pounds of 95-cent coffee. 24 pounds of $1.20 coffee and 11 pounds of 95-cent coffee. Or 11 pounds of $1.20 coffee and 24 pounds of 95-cent coffee. All right. So, very similar problem. Let's go ahead and break it down. Coffee worth this much per pound is mixed with coffee this much per pound. Whenever we see per pound, we can usually assume that there's going to be some sort of multiplication thrown in there, right? So I have coffee that's $1.20 per pound, and I have coffee that's 95 cents per pound, and I'm going to mix them together, add them together to equal a mixture that's $1 per pound. Do we know how many pounds of each type are used? Do we know how many pounds of each type are used? We do not. But what I can do is I can do $1.20 times X plus 95 cents times X. But is it going to be X? No, because X is the kind of pounds for one of them. What is the 95 cent going to be multiplied by? Let's think about that one for a minute. Let's move this over a little bit so we don't get lost in our tracks. And what is it going to equal? It's going to equal $1 per pound, but how many pounds is it? 35. Well, I can't just put an X here because I've already used the variable X to represent the number of pounds of $1.20. So X equals the number of $1.20 coffee. So how do I figure out how many pounds of 95-cent coffee I have? Well, what other information do I know? I know I have a total of 35 pounds. So if I have X amount of pounds for $1.20, then this is going to be 35 minus X. I take the total amount, I subtract the amount of $1.20 coffee, and it gives me how many pounds I have left over of the 95-cent coffee, right? So I have 120X plus, I'm going to distribute this through 95 cents times 35. $33.25 minus 95-cent X, because 0.95 times negative X is 0.95X, equals $35. And let's go ahead and make this smaller. And let's go ahead and move all of this so we can have a little bit more room. All right. I didn't think about that when I wrote the problem. So I'm going to rewrite all of that. 120x plus 33.25 minus 0.95x equals 35. Now I'm going to combine my like terms. 120 minus 0.95 is 0.25x plus 33.25 equals 35. Now I'm going to subtract 33.25 from both sides. 0.25x equals 35 minus 33.25, and that's $1.75. And then divide both sides by 0.25, and that equals 7. X equals 7. What is X? Now I know that C and D are out. X is the number of pounds of $1.20 coffee. X is the number of pounds of $1.20 coffee. So I know my answer is B because I have 7 pounds of $1.20 coffee and the rest is 95-cent coffee. Defining that variable for yourself in the beginning is super duper important because it allows you to see what you've just solved for. Now, what if that whole process was confusing for you? What could you do instead? Well, you could use your answer choices. You could sit here and figure out if any of these equal $35. Because keep in mind, if I mixed coffee A with coffee B, it's going to equal 35 pounds worth $1 per pound. 35 times $1 is $35. So let's go ahead and test that. 28 pounds of $1.20 coffee. Let's multiply 28 times $1.20. That equals $33.06 or $33.60. 7 times 95 cents is $6.65. When I add together $33.60 and $6.65, it does not equal 35. So that answer can't be correct. Let's go ahead and look at C and D. 24 times $1.20. That equals $28.80. And 11 times 0.95, that equals $10.45. $10 plus $28 does not equal $35. And last one, 11 times 120, that's $13.20. And 24 times 0.95, that equals $22.80. When I add $22.80 to $13.20, that equals $36. Still does not equal 35. But let's check out our answer. 7 times 120 is $8.40. And 28 times 95 cents is $26.60. When I add $26.60 and $8.40, that equals $35. Hence, why B is the correct answer. So you can either solve it completely algebraically or you can solve it using your answer choices. Either one works. Now, don't get me wrong. This one, I used my answer choices as a process of elimination, but I can't solve it using my answer choices. Whereas this one, I can solve using my answer choices. Does that make sense? All righty. Let's go ahead and do one more. Let's do one more. Which of the following geometric figures must have perpendicular diagonals? Must have perpendicular diagonals. Ooh, this is a good one. This is a good one. So, quadrilateral, parallelogram, rectangle, or rhombus. Quadrilateral, parallelogram, rectangle, or rhombus. So this is one of those that you kind of either just you know or you don't know. The quadrilaterals that definitely have perpendicular diagonals are square, rhombus, and kite. Now, if this was a problem that you were working with, you could automatically get rid of a quadrilateral, because a quadrilateral could be a rectangle. It could also be a trapezoid. It could also be a square. And all of those shapes couldn't possibly have perpendicular diagonals, because quite frankly, if they did, then all of these answers would be correct, because these are all quadrilaterals, right? So if quadrilateral was correct, then parallelogram would be correct, rectangle would be correct, and rhombus would be correct as well. So which of the following must have perpendicular diagonals? It has to be a rhombus. I like to remember that because it's my quadrilaterals with the same size sides. A square and a rhombus have to have equal sides. And so because they have equal sides, it allows for those diagonals to be perpendicular. In a rectangle, and I like to draw things super dramatically when I'm trying to prove or disprove this. And let's be honest, you and I both know that you can't just like assume it based on what your drawing looks like, because our drawings might not be extremely accurate. However, if I were to draw it, right, and I drew a super dramatic rectangle and then I drew my diagonals would look something like this, with an extremely obtuse angle on the top. Do you see that? So if I draw my rectangle not dramatic, the diagonals might look like this and they might look perpendicular. But if I draw it super dramatic, then I end up with these super obtuse angles, which is why I like to draw things dramatically. I mean, it comes from the theater side of me, right? So all that said, when you draw it, and I'm trying to prove or disprove something like this, I like to draw it super dramatically, and I'll show you what I mean. My iPad disconnected for just a hot second, but we are back. So if I drew a rectangle, I would draw it something like this, and then I would do my diagonals, and I would see that those are definitely not 90-degree angles. And then I would draw a super dramatic parallelogram, and I would notice the same thing. But there's not any way to draw a super dramatic rhombus, because rhombuses always have the same length sides, which is why you can prove or disprove that 90-degree theorem. Does that make sense? Like I said, that is not a really super mathematical way to go about it. But when you're taking a test and you're just not sure and you haven't committed that to memory, you got to have a test taking strategy, right? So there's my there's my not so mathy test taking strategy for you. My real test taking strategy for you is that you should know it, but there's going to be stuff on there that we don't know. So we just have to have a good strategy. All right. This was super fun. Let me know in the comment box. We are going to close up shop. I said that we were going to close up a couple minutes early. We are going to close up shop for tonight. Susanna, I have a student error analysis problem ready to go for next week. So get ready for that. And let me know what else you want to see from me next week. And I will see you then. Next week is my birthday week. So we will be celebrating with birthday cake. I will come with my slice of birthday cake if you come with your slice of birthday cake. My birthday isn't until Friday, but I just love a good birthday celebration. So we're going to just celebrate my birthday next week. Let me know in the comment box what you want to see me go over next week, and I am going to turn it back over to Dr. A.
All right, so wasn't that an amazing session? Now, I know, depending on what exam you have to take, you're like, man, that was great, but she didn't address everything I needed. She focused on all different questions, and I just need elementary, or I just need middle school, I just need high school. Don't worry. Since you're still with us, I've got a special surprise for you. If you the coupon code, all capital letters, SINK35, that's SINK 35. That will take off 35% off any of our prep courses on our website at the Learning Liaisons. Doesn't have to just be math. It could be anything that you need that we offer. And this is going to be an ongoing deal for you guys who attend these live sessions, because these are great. I'm sure Amy opened your eyes to some new concepts, some new ways to tackle problems, building that confidence. But this is just a smidget of your exam, the concepts on your test. So if you want the comprehensive view with the practice with Amy, with the practice test, with the lessons and the content review, we've got your back on our video boot camps, which all of them feature Amy Sink, your math specialist. So if you want to take advantage of that, the code is SINK35. You can use that at checkout on the learningliaisons.com website. And all that information is on our website as well, and on the bottom of the screen in this video. So we are here to help you. Once again, always remember, it's when you pass, not if you pass. Thank you for joining us again today, and hopefully we'll see you next week too. Talk to you soon.